and welcome to the second session of dynamics. In case you are looking for me, I'm in the top right corner of your page. Hopefully you are doing good. So I'm going to go have a very quick recap of what we talked last time about kinematics of rigid body. So we talk about rigid body meaning that we are not talking about one point, we are talking about millions of particles. So before we start rigid body, we should have an understanding of what types of motion we are talking about. Then as we classify motions, that will help us to know what types of equation we can use. So the topic for this specific video is about relative velocity in the vector approach. So relative velocity meaning that if I have 1, 2, 3 objects, they are connected together. If I know velocity of one, how can I find the velocity of the other one? Now, in the type of motion, we start with translation. Translation would be any object which is going such that all the velocity in the rigid body is the same, acceleration is the same. Look like you are driving your car. Every particle on the car, they go with the same speed. That's translation. The second types of motion called rotation about fixed point. Rotation about fixed point, like I have my pencil and I rotate it. The third option is general motion. Now on the rotation about fixed point, if we have alpha and omega, I'm going to have a recap that omega is angular velocity and alpha is angular acceleration. Now in this bar, I am applying an alpha and omega. I want to find how much velocity of it is. So velocity we already know in circular motion, velocity is radius times angular velocity. So it will be r omega ab. Now, in case of acceleration, at every point we have two types of acceleration. One acceleration is from normal, the other one is from tangent. So the normal acceleration is r alpha, and then the normal acceleration is v square over r or r omega square, and tangential acceleration is simply called r alpha. Now, in case of general motion, like in this picture that we have, if we know velocity of A, how can we find velocity of B? Now we can say velocity of B is equal to velocity of A plus, again, down here I have a mistake, I need to correct it. That's actually omega cross R, not R cross. So it will be omega AB cross with RB with respect to A. So omega cross R, so we say velocity of B is the same as velocity of A plus the rotation part of it. Now similarly, when we differentiate this equation to the equation down here, we'll get into a separate equation. Now VA, the first derivative of VA will become AA, then we have omega, then omega will become alpha. As we go through, and then because this is going to be, again, we talk about that in the other lecture, we ended up as the equation that you can see it here. Now, in order to solve the problem, we're going to identify the types of the motion. Now, again, I noticed that I have the same mistake here too. So that will be alpha AB cross with RB with respect to A. Now, identify the type of motion, apply the relevant equation, and start from one point and get it to the other. So before I go ahead, I just want to give you a little bit about made it easy for cross product. We don't want to do all those determinant and find all the options. What I do, I have a very quick method. This quick method, we call this IJK, like draw three axes like this, X, Y, Z, if you remember. Now, in the rotation, if we rotate counterclockwise, we are positive. If we rotate clockwise, that becomes negative. Now, if I want to do I cross J, so I cross with J would be equal to K, because if you go from I to J, you're going to go in the direction of counterclockwise, like this. Now, if I want to say J cross I need to go the opposite way. I'm going to go clockwise, so I'm going to say minus K. I cross K is minus J. Again, if you say K cross I, that will be positive J. J cross K because we are going counterclockwise. This will be I. If you have, again, in cross product, if you cross two vectors that are the same, I cross I is 0. We already know about that. Because for this actually is used sine theta. The angle between the two vectors become 0. Therefore, there is going to be no cross product for when they are the same. So I want to do one example using the vector approach. In this example 1, the question asked me to find omega BC and omega CD if we know omega AB is equal to 30 radian per second. Now, we're going to go with the type of motion. AB, I can see this is rotate about fixed point A. So velocity at A is 0 because this is a fixed point. Then I want to find velocity at B. Now, in order to find velocity at B, this is a vector approach. There are two ways I can do. Either I can say velocity of B is equal to velocity of A plus omega AB crossed with RB with respect to A. That's one way I can do. The easier way is just look at it, right? If you look into this bar, you can see the angle here is 60 degrees. Then the angle here will be 30 degrees. The angle here will be 60. Then the angle here will be 30 degrees. Now, velocity at B will be perpendicular to the RAB, to the bar AB. Then when it's perpendicular to bar AB, the magnitude of it will be 6. Now I can break it down. The X will be cosine, the Y will be sine, right? It's just completely clear here to me. Now your X component will be 6 cosine 30, the Y component will be minus 6 sine 30. If you simplify it, you're going to get 5.19 I minus 3J. That's velocity at B. Now, I know velocity at B and its component. I exactly know the equation for it. The velocity at C, I know that if you look into the wheel CD, this wheel is actually rotation about fixed point. And that fixed point is simply the point of D. Right? When this fixed point is the point of D, I can say velocity at C again will be perpendicular to this R, and then I can say velocity at C is equal to 0.1 omega CD. So I have a picture like this. So in this picture, I already know velocity of B is equal to 5.19 I minus 3J. At the same time, I know velocity of C is actually equal to 0.1 omega CD I plus 0J. Why put 0J? Because it doesn't have any J component. It's all on positive X. Now I can actually set up the equation here and solve it. Now velocity of C is equal to velocity of B. Let's follow the same equation for vector. Then I can say velocity of C is equal to velocity of B plus omega BC cross R. Again, because I do C, I'm going to be RC with respect to B. Because again, this is the B is going to be the beginning and C is the end. Then the R that I'm going to use is going to be R of the second one compared to the first one. Now, R of the first one compared to the second one is the second one compared to the first one will be R of C with respect to D. Now, R of C with respect to the point C, how far is located compared to point B? Then again, we need to consider x-axis and y-axis. If this is y and down here is the x, then you can simply say, you would simply say that RC with respect to D is equal to the length of this, which is 0.2. So RC with respect to D is equal to 0.2 I. Because it just have, if you look into the point C with respect to point B, you would say that, sorry, this down here is B, C with respect to B, not D. C with respect to B. Now, I can actually finish this problem. In this problem, velocity of C, which is, so let me just remove the touch. Yeah, velocity of C which I already have it. I have 0.1 omega CD plus 0j is equal to velocity of B, which is 5.19 I minus 3j plus omega BC. Omega BC I don't know. I do not know omega BC, but I know omega BC is in the direction of K. You see the rotation, how it looks like? So that's going to be actually in the direction of K, but I do not know exactly how much the value of it is. So I'm going to say omega BC K, that has the direction of K, cross with 0.2 times I. Again, my pen stopped working. I'm going to just do this type of it with the touch. So cross with 0.2 I. Okay, now I'm gonna split here. So I have K cross with I. So K cross with I want to see what is that? K cross with I. So let's go up a little bit to where we did the method I explained to you. So K cross with I is simply J, right? Because K cross, if you go from K to I, you're going to go counterclockwise. So K cross I is simply J. Then in this case, this would be simply equal to J. Now, I'm going to finalize the problem. In this problem, I have 0.1 WCD. Again, I forgot the I here. There's the I here. And the other side, I have some components. So let's just simplify something like this. In the right side, I have 0.1 omega CD plus 0 in J. In the other side, I have 5.19 I minus 3j, and I have 0.2. The answer is J, right? So plus 0.2 omega BC into J. Now, what we could say I in one side is equal to I in the other side, and J in one side is equal to J in the other side. So overall, you ended up as two unknowns and two equations. So I is equal to I, and J is equal to J. Now, what we have I for the right side, for the left side, we have 0.1 omega CD is equal to, on the left side we have, that was on the left side. The right side we have 0.519. For the J, on right side I have 0, on left side I have 0, on the right side I have minus 3 plus 0.2 omega BC. Now from here, omega BC is equal to 3 divided by 0.2. This answer would be equal to 15, I guess. So that's 15. Then I know, and then I can, over there I can calculate the omega CD2. So sorry, there's no I here. That's my bad. Not going to be any I here. So omega CD is equal to 5.19 divided by 0.1. The answer is 51.9 radian per second. So let me just check my answer. Yeah, looking good for both of them. So 51.19 radian per second, and the other one is 15 radian per second. Thank you for watching this video. I'm going to post a different method which is much easier than this method, and that's called center for zero velocity. Now, if we know where the center of zero velocity is, we don't need actually to do all this cross product and using this vector approach. So looking forward to see you in a minute. Thank you. Bye-bye.